Good evening, all of you. Good evening, all of you. Welcome to this live session. Welcome to this live session on these two-port networks. Welcome you all of you. Am I audible to all? Am I audible to all? Everybody, good evening all of you. Welcome you guys. And today we are going to discuss about this two-port networks and what is a two-port networks, what are the different type of two-port network parameters. We are going to analyze in deeply, completely we are going to analyze here. Chaliye, let's start our discussion all of you. Let's start our discussion all of you. Let's start our discussion, everybody. Am I audible to all? Two-port networks. And these two-port networks, for the discussion of these two-port networks, okay, so alternative days I'm planning the 1 hour class, and nearly within 5 sessions I'm trying to complete the complete syllabus. If it is required, we'll take the 1 more 5 sessions we'll take. Initially we planned the 5 sessions we planned, so if it is required, we'll plan the 1 more 5 session, we'll plan it. Chaliye, let's start our discussion, all of you. Yes, and myself, I'm BV Reddy. You can see this thing here, and I'm the one of the topmost educator in this Unacademy. And here we are starting for the SN 2 years batch, and this batch which we have designed exclusively for the second year students, third year students and final year students. This batch exclusively we have designed for the second year, third year, final year students, and we'll plan to cover the complete syllabus of your semesters, and at the same time we'll cover all the GATE as well as ECE complete syllabus will be covered. And the students which are willing to take the subscription details and all, you can contact me here in this number. You can WhatsApp me or you can call me, and you can use this code. This is my referral code. By using this referral code, you will get a 10% discount. You will get 10% discount. You will get. Next, and the next we are going to start this explore batches, and this is for the semester exams. This we can say semesters for the third semester, second year, first sem, and for electronics and communication engineering. Here you can see this is I am BV Reddy. I am the topmost educator in this complete Unacademy platform, and you can achieve this thing. You can see this thing here. If you want any further details, you can contact me in this number. We are starting this batch electronics. At the same time we are starting for the electrical also. We are starting this batch. You can see this thing here. I am the BV Reddy here. You can see my and the topmost educators, and here you can find the topmost educators of this India. So this is Suresh VS sir and Siddharth Sabharwal sir, Trinath Reddy sir and Kaiser Hafiz sir, Dinesh Gupta as well as a Uma Maisro sir. And you can find the topmost educators in this Unacademy platform. Right, and this is also SN2S batch for ECE guys. And the students, you can use this code. This is Baby Reddy, my referral code, and you will get the personal guidance from my, and you can contact me in this number. Right, and here, so you can see, you can search my profile now. There you can find the topmost educators. Right, and what's the benefits you can see. So you can, आपको मिलेगा पर्सनल गाइडेंस मिलेगा इधर, and 24/7 dedicated doubts clearing WhatsApp group we have. If you have any doubt in any subject, you can contact me. You can WhatsApp me this number. Yes, आपको immediately तुरंत आपको डाउट्स के लिए सॉल्यूशन मिलेगा. And the DPP for the subjects, daily practice problems for all the subject what we are discussing and all. And the students which are you interested to take this subscription, and they can use this code, the BB Reddy, then you will get the 10% of discount you will get. Fine, let's start our discussion now, all of you. Right, the two-port networks, first of all, what is meant by port? Two port, one port, three port, let us say. What is meant by port is a port means a pair of terminals. Through which signal can enter or leaves. Here, what is meant by signal? The word signal, so the meant by signal is a signal means what now? It may be a voltage, may be a current. Simply in general we can call this as a signal. Signal means it may be a voltage, or we can treat it as a current. The port means a pair of terminals through which signal can enter or leaves. If you have considered this network like this, consider a random network like this. This is, I am calling this as a one port network. And this one port network means what it has a, yes, one pair of terminals for the signal to enter, and the signal has to leave. This is called as a one port network. Here the signal can enter and the signal can leave. This is called as a one port network. It has only single port, right? Consider another type of network like this. this is the another network. If I call, let us say this network has the ports like this, V1. Let us say the signal can enter. Whatever the current is entering, the same current has to return to the negative terminal. And here this current, this voltage, I am calling it as a V2. This I am calling as I2. The same current has to leave. Yes. Now what I should call this is, now tell me. Yes. What I should call now, this is called as a two-port network. This is called as what? Two-port network. Right. If I consider one more network like this, another type of network like this. So let us say this is some network, and this network has a ports like this. Consider this network has a ports like this. Consider so many ports we have. The ports might be like this, I can say. Yes, here is a port 1. Let us call this is the second port. Let us say this is the third port, and let us call this is the fourth port. How many ports are there? 4 ports. This type of network, what I should call this type of network is called as a multi-port network. What we'll call this type of network is a multi-port network. This is called as a multi-port network. This is called as a single port or one port network, two port network, and this is called as a multi-port network. And here our complete discussion is about this two port networks. Our complete discussion is about what? Our two port networks. So let's discuss about our two port networks. Fine. Let's enter into the two port networks. In the two port networks, you can see here totally how many variables you can see here. What are the variables you can see? How many variables are there? The variables are what? V1, V2, I1, I2. That means totally how many variables we have totally? 4 variables are there. Totally how many variables we have? 4 variables we have. Among these 4 variables, what we are doing is, I am selecting at a time, I am selecting 2 variables, I am selecting as a independent. 2 variables, I am selecting this thing as independent. Two variables I am selecting as what now here? Independent variables. And the remaining 2 will be dependent variables. The remaining 2 we are calling this as what now here? Dependent variables. Two variables I am selecting as independent, and the remaining 2 will be dependent variables. Yes, how many waves I can select? Among 4 I need to select 2 I need to select now. How many waves I can select now here? Tell me. How many waves I can select now? Totally we have 4 variables we have. Among these 4 I need to select at a time. Only 2 variables I need to select now. How many waves I can do the selection now? Tell me. How many waves I can do the selection now here? 4C2. How many waves I can able to select it now here? 4C2 I can do. Yes, so how much the 4C2 means what now here? 4 into 3 by what now? 2 into 1. So that means how much this value now? It is 6. This value is 6. That means what we can say now here? So we can able to form a 6 different type of variables are possible. 6 different type of variables are possible. Right? 6 different type of variables are possible by using these 4 variables, and those 6 different type of variables we are going to discuss now. Right? And yes, before going to the 6 different type of variables, let us have some brief introduction about the different type of networks we will see. Yes, take down first the network. Here we will call this as a symmetrical network. What we can call this as a symmetrical network. What is a symmetrical network? The name itself indicates symmetrical. So for example, if we have a network like this, consider we have some network keys like this. If this network, let us consider this is a 2 ohms, this also 2 ohms. Let us say this is a some what I maybe some, I'm calling this as a some 10 ohms I'm calling. Yes. Is the network is symmetrical or not, I'm asking. Is this network is symmetrical or not? Yes or no, symmetrical or not? Tell me. You see, symmetrical or not? Yes, you can see here. So symmetrical means when I fold it now exactly has to overlap. So can I divide this network? Can I treat this network as a like this, 2 parts? I'm treating this network as like this. Can I treat like this? This is the 2 ohms and this is the 2 ohms, and how I should call this is my 20 if I say, and this is another 20 if I say. Now you can see now here about this line here, and the complete the network will be seems to like a mirror images. About this line the network will seems to be like a mirror images or not. If I fold it now exactly will overlap now. The network will completely will overlaps, isn't it? So this type of network we'll call this as what we can say here, symmetrical network. This type of network is called as what? Symmetrical network. So how we can identify the in general case now here, symmetrical network means what we can do here. If I call this is a network, in this network this is my port 1 and this is the second port. Here the port 1, this voltage I am calling as V1 and this current I am calling as I1. The same current has to return. Whatever the current is entering, the same current has to return. And this I am calling this as a V2. This I am calling this as I2, and the same I2 has to return. So in this case what we can say symmetrical network means, what we can say, the ratio of excitation to the response, a response at one port is same as the ratio of excitation to the response at the second port. This type of case we'll call this as a symmetrical network. Here I can see if the ratio of excitation to the response at one port is same as the ratio of excitation to the response at the second port. That means here you tell me this thing, the ratio of excitation, here this is my excitation and this is my response. What the ratio of what now? Excitation to response at the port 1, that must be same as what now? Here the ratio of excitation at the second port is what now? V2 by I2. If this condition satisfied, then we can call the network is said to be a symmetrical network. Then the network is said to be a symmetrical network. Right. One more condition thing, we are going to discuss another type of network, that is a reciprocal network. Reciprocal network. A reciprocal network means, simply reciprocal network means, previously we have discussed the network theorems, reciprocity theorem. The network which satisfies the reciprocity theorem, that type of network is called as a reciprocal network. What we can say here, if the network satisfies the reciprocity theorem, then the network is said to be reciprocal network. The network is said to be a reciprocal network. Means what we can say here, if I call this is my network, this is my some network, the two port here, what's this is my V1 and this is my I1 and this is my V2 and this is my I2. What we can say, reciprocity theorem means what now here? For the reciprocity theorem, the ratio of excitation to the response remains constant even though excitation and responses are interchanged. The ratio, what we can say, this is V1 by I2, excitation to response, yes, which must be same as what we can say here, V2 by I1. If this condition satisfies, then the network is said to be a, this is called as a reciprocity theorem. If the network satisfies the reciprocity theorem, then the network is said to be a reciprocal network. Yes, the excitation, what is the reciprocity theorem now here? The ratio of excitation to the response remains constant. The ratio of excitation to response, when you call this is my excitation, so at a second port is my response. when I say this is my excitation and this is my response. Right, all of you? Everybody? Done till now? Any doubts till now? Any doubts now? Yes? Let's go to the next one here. Now let's start the another type of different type of parameters we are going to discuss one by one parameters. Take the first one here. The first class parameter, we are calling this as a Z parameters. Z parameters. The first parameters we are calling this as what? Z parameters. In case of Z parameters, among we have what we have? V1, V2, I1, I2. These are the four variables we have. Among these four variables, and as I told, at a time we'll take the two as a dependent and two as independent. In case of Z parameter, I'm selecting these two as a dependent and these two I'm selecting as independent. These two parameters I'm selecting this as a dependent. These are the dependent variables I'm calling, and these two I'm calling it as independent variables. These two I'm calling it as what? Independent variables. Now, so then here let's see those parameter equations. That is, V1 is a dependent V1, yes, which we can call this as a function of what we can say this is I1 comma I2. We should express now. V1 is a function of I1 comma I2, and this V2 which is also a function of, so this is I1 comma I2. I need to express it. Yes, these are called as a Z parameters relation. Those Z parameter relation we are going to see. That is V1 which is equal to Z11 I1 plus Z12 I2, and V2 which is equal to Z21 I1 plus Z22 I2. These are the Z parameters relations. These are what? Z parameter equations. We can try to express this in a matrix form. We can express it. How we can express a matrix form? This is V1 and this I'm calling as V2. Yes, which is equal to what we can say this is Z11 matrix, Z12, Z21, Z22 into what we can say this is I1, I2. This is I matrix. Right, and I can simply treat this thing as what we can say this, we can call this as V matrix, which is nothing, is given as what I can say here, Z matrix into I matrix, V matrix which is equal to Z matrix into I matrix, where this is a Z matrix. This is the Z matrix. Right. Now let's talk about these parameters now here. Z11. What is Z11 is how to get the Z11? You can see this thing, the Z11, which is to get the Z11, I have to make this term is 0. That is what we can say this is V1 by I1 when I2 equal to 0, V1 by I1. For that I2 must be equal to 0 now. And tell me the units now. V1 by I1. This is the voltage by current now. So what I can say, this is the units are ohms. So that means ohms means which in the form of like impedance now. Impedance. So that's why this name of Z11, which is called as a driving point, input impedance. This is the port 1 now. We can call the port 1 is the input, port 2 is the output. Driving point input impedance. Driving point input impedance. Yes. Next, second one, Z21. Tell me Z21, what we can say is Z21. To get the Z21, which is given as what we can say, V2 by what? I1, when I2 equal to 0. And what are the units now here? Ohms. What are the units now? Ohms. So what we can call this is now, tell me. What we can call this is a, what we can call this as voltage by current. So this should be impedance. And you see this thing here, but this impedance is not in the same port. Voltage in the port 2 and current in the port 1. Generally output, second port is the output, first port is the input. Output by input, which we can call this is in the form of forward. Yes or no? So that what we used to call this is a forward transfer impedance. Forward transfer impedance. This is called as forward transfer impedance. Next, Z12. What I should call a Z12, tell me. This thing I should get now. What now here? This is nothing but V1 by I2 when I1 equal to 0. I1 equal to what? 0. What are units now? Again, it's a ohms are only the units. Again, the units are ohms only. Now tell me the name now. What I can give the name now here? First of all, if it is same port, we can call this as a driving point. So this is what now here, it is not the same port. So we should got transfer. What type of transfer? Forward transfer, backward transfer, we need to see. So here, this is the, if the numerator, it should be a output, we can call forward. If it is denominator is output, we can call this a reverse. So this will be what I can say now, forward transfer, reverse transfer we can say. This is the denominator will have output now, output term. So this is called as a reverse transfer impedance. Reverse transfer impedance. Everybody? Next, what about the Z22? Tell me now here. Z22, which is given as what I can say, this is V2 by I2. V2 by I2 when I1 equal to 0. When I1 equal to 0. The units are ohms only now. Now tell me what I should call this is. Look at now, same port or different port. First of all, to give a name, same port. If the same port, we can call driving point. And where this impedance now here, input location, output location, second port. Second port we can call this as what now here? Output. So what we can say, this is now here, name now here, driving point output impedance. driving point output impedance. Right, all of you? This is about these parameters, you can see, Z parameters. And if you see carefully, and what's the units of this, all these parameters, so you can see all the units are what it is, ohms only. The units are, all the units are what, ohms only. Means what we can say here, these are the ohms now. That's why these are called as a impedance parameters. These are also called as what? Impedance parameters. These are also called as what? Impedance parameters. And you can see here, to get these parameters, what I should do here, I have to make the I2 has to be make 0. I2 has to make 0. I1 has to make 0. This means what I should do here, so port 2 has to open and port 1 has to open. That means what I should do here, so to get this Z11 and Z22, I should make the second port has to open circuited. Here first port has to open circuited, isn't it? That's why these are also called as open circuit parameters. These are also called as what parameters? Open circuit parameters. Z parameters, impedance parameters are also called as what? Open circuit parameters. Right, all of you? And you can see, here, observe these equations now here. These are the parameter equation, equation 1 and equation 2. If I call, you can see this thing here. So this is like a one KVL equation. Yes, this is the second KVL equation now here. So for this KVL equations, let us develop the network. Let us develop equivalent network. Let us try to develop the equivalent network. That is what now, this is the KVL equation. Let's develop the equivalent network. How we can develop this network now here? We can see this is what the equation we have. V1, which is equal to what? Z11 into I1 plus what now here? Z12 into I2. Let's see this part, first part, input part. So what I can do here, this is a port 1. I can treat this as some impedance. This is what I can say, Z11 if I call Z11. Yes, you can see this is my V1 and this is my I1. By applying KVL, we should get this equation. We should get the current of I1 in the loop now here. You can see this thing here. V1 is equal to Z11 I1. So this term is over. And this term we should get now. Plus, if I make this as, what we can say this is now, Z12 into I2. Check it now. Will be satisfied or not? Next, second port. For the second port equation, tell me. For the second port equation, V2 is equal to what? Z21 I1 plus what? Z22 I2. Let's develop the second port equation also. Second port equation. This I am calling it as a second port, port 2. This is my Z22 and like this. So this is my, I can call this is my V2. This current is what? I2. And this is what I can say here, Z22 into I2, and I am connecting this as by a line here. This is my common ground. Check it now here. By applying a KVL to the second in this loop, you will get the second equation. You will get KVL to the first loop, will get the first equation, will get or not. So we can call this is the equivalent circuit. So we can say this is the equivalent circuit in this case. Everybody understood? All of you? Now, for in this type of network Z parameters, let's see the condition for reciprocal as well as symmetrical. As we have seen symmetrical condition, when we can say symmetrical, when we can call the network is symmetrical, for the condition of symmetrical condition is what here? Yes, that is Z11 must be equal to Z22. This is the symmetrical condition. Yes. Now let us see the reciprocal condition. The reciprocal condition. Reciprocal condition, which is what here? Z12 which is equal to what? Z21. If these conditions are satisfied, we can call it symmetrical. This is what the reciprocal. Fine. This is about the Z parameters. Now let's move to the next one. Next parameters, that is Y parameters. And the parameters are what we are calling this as a Y parameters. Yes, in case of this Y parameters, what we are doing is I am taking this as a I1, I2 I am taking as a dependent, V1, V2 I am taking as independent. Now here these are the independent, and these are what? Dependent. Now let's develop the relations here. That is I1 equal to Y11 V1 plus Y12 V2. Next I2 is equal to Y21 V1 plus Y22 V2. In the matrix form we can write it as I1 I2. We can express this as I1 and I2 now here. These are the Y11, this is Y12, Y21, Y22, and this is the V1 and V2 now. This is the matrix form. And here this matrix we can treat it as, this is like a I matrix, and which is equal to this we can treat it as like a Y matrix, and into this we can call this as V matrix. This we can treat it as what now? V matrix. Now let's talk about these parameters now here. Let's talk about these things. Here, let's find one by one parameter. Here this Y11. Tell me Y11. How to get this Y11 now here? Which is nothing but I1 by V1 when V2 equal to 0 now. And you can see the units now here. This is the current by voltage now. Most units are what? Most now, Siemens. And what I can call this name of this thing? what the name I can give here? You can see here input current by, this is admittance, and same port a different port. Same port means we can use the word of driving point. If it is same port means we use a word, what we use the word, we use driving point. So what I should call this as a, this we can call this as a driving point. Yes, this we can driving point, input admittance, this is the driving point, input admittance I can see. Right, next y21, tell me y21, how to get this y21, which is nothing but what now here, I2 by V1 when V2 equal to 0 now, and whatever the units are most only now here. Tell me what the name I can give. Same port or different port? Different port. Forward or reverse? Forward. So tell me now what I can call this is now here. This is the forward. Yes, forward. Transfer now here. Transfer admittance. Right. Next y21, so y21 over now y12, y12, y12. What is the y12? Tell me. This thing, which is nothing but what I can say, this is I1 by V2 when V1 equal to 0, and the units are what? Moles. Yes. Tell me what I can say, this is now here. Forward or reverse? Reverse, not the same port. Transfer. Tell me what I should call this is now here. Reverse. Transfer. What? Admittance. Yes. Reverse transfer admittance. Next y22. What the y22 is called as? I2 by V2 and V1 equal to 0. Yes. Tell me what I should call this name is a same port. Same port. So we can call this as what we can say. So this is a driving point. Yes. Output admittance. Driving point, output admittance. Right. Now, yes, like previously we have some equivalent circuit. Here also we will try to develop equivalent circuits for these two input equation as well as output equation. Let us try and see this equation 1, which is in the form of what I can say Kcl, and this is also Kcl only now. Yes, these two are what? Kcl equations. So Kcl equation we will try to develop it. Fine. Try to develop it now here. First equation. Yes, what now here? I1 is equal to what? Y11 V1 plus what? Y12 V2. Let's try to develop the corresponding equivalent here. This Kcl now. Kcl, the algebraic sum of currents at a node equal to 0. Sum of entry currents equal to sum of leaving currents. Let's try to develop it carefully. Now here this is what we can say, this is my V1 and this current is my I1. You can see this is I1 is equal to this voltage V1, so this should be a Y11, and this is the current now here, this should be what we can say, this is Y12 into V2. Now apply the KCL at this node. By applying KCL at this node, you tell me what will get now here. Sum of entry currents at this node equal to what I can say, sum of leaving currents. Sum of entry currents equal to what? Sum of leaving currents, I can say. This is the Kcl equation. Everybody? Yes, we'll get this equation, we'll get it or not? Next. Tell me now the second equation is what we have. This is I2 is equal to what now here? Y22 V2. Y21 we can write carefully. First we can write here Y21 V1 plus Y22 V2. Try to develop this equivalent now here for the second port. This is also KCL only now. Second port is also KCL. Sum of entry currents equal to sum of leaving currents. Yes, this I am calling this as a V2. This current is I2, and this is what now here, Y22, and this is leaving current. What we can say, this is Y21 into V1. Join karo these two. If I join these two, and then we can make it as a common ground. Check it now. By applying KCL at this node, we can get this equation. We can get now. We'll get this equation. Right. And here also we can see the condition for symmetrical and reciprocal. Symmetry conditions. Symmetry condition. And what's the condition for symmetry? This is Y11, which is equal to what? Y22. And what is reciprocal condition? Reciprocal condition. This is what? Y12, which must be equal to Y21. Right. And here you can see here one more thing you can see here. And what are the units of this each parameters are? Mhos. Mhos means admittance, right? So that's why these are also called as admittance parameters. These are also called as what? Admittance parameters. Yes, and what else now here? You see this thing, to get this thing V20, V20, V10, V10 means what now? Port 1, port 2, we need to short now here. Voltage 0 means that is called as a short circuit now. So that's why these are also called as a short circuit parameters. These are also called as what? Short circuit parameters. Yes, right. And previously we have discussed about the impedance parameters. Now here we have discussed about the admittance parameters. Right. Now let's try to find the relation between the impedance parameters and the admittance parameters. Yes. Look at now here in case of a Z parameters. Z parameters. We have seen a relation here, that is V matrix, which is equal to what we can say this is Z matrix into I matrix. V matrix equal to Z matrix into I matrix. Right. In case of this Y parameters, what we can say this is this I matrix, which is nothing but what we can say Y matrix into V matrix. Everybody? No. So no either. Look at now all of you. So this is my V. I am multiplying this thing, this equation, like a matrix thing we are doing. If I multiply with a Z inverse, here we are doing a pre-multiplication. Z inverse if I do, then you tell me what will get now here. This is pre-multiplication of Z inverse. This is Z inverse into Z and into I. Check it, everybody. So that means what we can say, this is Z inverse into V, which is equal to, as we know, A into A inverse is nothing but I matrix, identity matrix now here. So then by multiplying this thing, it will becomes 1 into I matrix into I, means we will get the current matrix. We will get now current matrix. So that means what we can say, this is I matrix, current matrix. Here the I means current matrix, which is equal to what we can say, this is Z inverse into V matrix. Everybody? Yes, understood this thing here? Here this thing. Now can I compare this relation with this relation? Can I compare this equation with this relation? Can I compare it or not? If I compare these two, then see what I will get then here. By comparison, I matrix only. So here from this, what we can say, this is Y matrix, which is equal to what we can say, this is Z inverse. Everybody? Y matrix equal to what? Z inverse. If I take the inverse again, what happens now here? Y inverse, which is equal to what happens now here? Z inverse and whole inverse. So this, as we know, this according to matrix property, if we take the 2 times inverse, we'll get this original matrix. You can get now. You will get this original matrix. You will get, everybody. So now this is the relationship between the Y matrix and the Z matrix. So by using this relation, if we know the Z matrix, from that we can get the Y matrix, and Y matrix we can get the Z matrix. Vice versa we can do. Fine, all of you? Everybody? Any doubts now here? Any doubts you can ask. If you have any doubts, you can please ask your doubts. Yes, fine, all of you? Done. So this is about the Y and Z parameters we have discussed in this today's class, and the next class will continue the remaining parameters and will solve all the problems we'll discuss. All the variety of problems we are going to discuss it. Fine. That's where today's class will meet in the next class. all of you. See you. Bye bye.